Hi, this is Jeff Hamrick at the University of San Francisco in the Financial Analysis program, and I'm going to talk about using the tabulate command in Stata to summarize categorical variables, and then how we can use the tabulate command to have Stata create dummy variables automatically for us. So what I've got here is the Kelley Blue Book data that we used in class. Remember that this data relates to about 800 cars and information about those cars from Kelley Blue Book, including their price in the opinion of Kelley Blue Book, their mileage, and variables like the make, model of the car, whether or not the car has leather seats, and so on and so forth. So most of the variables in this data set are categorical, and we would use a command like summarize to summarize a variable that's quantitative. But what do we do when the variable is categorical? We probably want to use the tabulate command. So here's a simple application of the tabulate command. If I wanted to tabulate the makes that are available to me in this data set, I would use the command tabulate followed by the name of the variable of interest, which in this case is make. And what we see from this summary is that we've got a total of 6 makes of cars in this data set. Most are Chevrolets. We have some Pontiacs and Saabs, and lesser numbers of Buicks, Cadillacs, and Saturns. Tabulate also works for creating cross tabulations of 2 or more variables. So for example, if I do tabulate make and let's say cylinder, I get a 2x2 table of the variables in this data set, of the cases in this data set. So that is to say, for example, we have relatively few 8-cylinder cars in this data set, only 100 out of about 800 cars. We have about 300 cars with 6 cylinders and about 394 cars with 4 cylinders, and you can see the breakout amongst the makes by looking at this basically 2x2 table, okay, or two-way table. So that's how we can use tabulate to look, if we don't have too many variables to consider, to look at the way that 2 variables intersect if those 2 variables are categorical in nature. So you might be interested in regressing, let's say, the price of these cars against the make of the cars. But if you were to try to execute that regression in Stata at the current moment in time, that regression would fail. Basically, the issue is that Stata does not regard make as being a quantitative variable, and ordinary least squares regression is going to require us to work with a quantitative variable. So we've got to somehow convert the variable make into a collection of variables that are quantitative in nature and have the same information in them that is contained in the name Buick, and the name Chevrolet, and the name Pontiac, and the name Saab, and so on and so forth. And we do this, as we discussed in class, with dummy variables. So creating these dummy variables ourselves we could do with the gen command, but it's a little inconvenient and a little annoying to create 6 variables and to write the if-then statements that would be required to have these variables. It's perhaps a better idea just to use an option under the tabulate command. So here's how we use that command. We would say tabulate, and we would tabulate make, but then I'm going to put a gen command after it. I'm going to ask it to generate a set of variables that will be indexed by the letter M, which is just a variable name. I could put any name here. I could put my name, Jeff. I could put the word fudge here, and so on and so forth. And what that's going to do is create a collection of 6 dummy variables that correspond to the states of make in this data set. Why 6? Because we have 6 different car types. And how will the dummy variables work? Well, let's just execute this and see what happens. So when we execute this, we get the same basic table right here, but what really has happened here is that Stata has gone on ahead and created variables M1 through M6. So that name M that I used was used to create the left-hand portion of these variable names. And it's M1 through M6 because we've got 6 different states of the categorical variable make. And you see right here in these labels that it's told us what these dummy variables do. M1 corresponds to the number 1 for those cases in which make is equal to Buick. It's 0 for all other cases. M4, on the other hand, is equal to 1 when the make of the car is equal to Pontiac, otherwise it's equal to 0. Okay? So you can check this out. You can inspect this data, once again using the browse command, and you see sure enough that, for example, with these first cars that were all Buicks, the M1 variable is equal to 1 and all the others are equal to 0. But if we scroll down to when we then have Chevrolets, or whatever the next one was, Cadillacs, Cadillacs, then this dummy variable turns on and all the others are equal to 0, and so on and so forth. Now we could perform a regression, in this case a multivariate regression perhaps, involving M1, M2 through M6. Okay? So here's an example of how we do that real quick. What if we wanted to regress price against M1, M2, M3, M4, M5, and M6? This is how we'd proceed. Now you'll notice that all of those variables got included except for one, M6. And it says there's this note from Stata that M6 got omitted because of collinearity. Well, if you think about it, the 6 variables are redundant, right? If I tell you, for example, that my car is not a Buick, not a Cadillac, not a Chevrolet, not a Pontiac, and not a Saab, you automatically know that it must be a Saturn. Okay? So you really don't need 6 different pieces of information to encode the idea of what is this car's make. You only need 5 pieces of information for that. So we should have only put M1 through M5, or M2 through M6, or all of the M's except for M4. One of them is unnecessary. Okay? So I won't interpret this regression table here since we do that in other videos, but this is how you use Stata and the tabulate command to summarize categorical variables and then to create dummy variables that correspond to those categorical variables. Let me know if you have any questions.